Hey everyone, and welcome back to another AlgoSkills LeetCode tutorial video. In this video we're going over LeetCode 2718, sum of matrix after queries. So in this video we're going to kind of break down the question. We're going to move over to the whiteboard, break down how we're going to actually solve it, and then we're going to of course write the code for the solution. So before we get into that, let me just say, if you're serious about getting better at data structures and algorithms, you want to land that dream job, then I would highly recommend checking out our course AlgoSkills. The link will be in the top of the description. I'm an ex-Amazon software engineer. I've gotten into FANG before. I teach you the skills required to get there. So if you want to get into one of those top tier tech companies, I'd highly recommend checking out AlgoSkills in the link below. So let's get into the question. We'll just give it a quick read first. So you are given an integer n and a zero indexed 2D array queries where queries equals type, index, value. Okay, so we just have an integer n, and then we have a list of a bunch of queries which are in this specific format. Cool. So initially there is a zero indexed n by n matrix filled with zeros. For each query you must apply one of the following changes. So we have the type 0. We need to set the values in the entire row that they specified to the value that they specified, overriding any other values. And then for type 1, it's the same thing but for columns. So we need to set all the values in a column that they specify to the value that they specify, again overriding any existing values. And then we just return the sum of all the integers in the entire matrix. So I think it's pretty straightforward when we look at an example. So I'm going to, rather than going through them here, I'm going to move over to the whiteboard now, and we're going to go through this top example here and kind of look at it. So we have an input which is n equals 3, which is why we have a 3 by 3 matrix. And then we have a list of queries here. So we have 1, 2, 3, 4 queries, and then the output is 23. And I've just added a little note here at the top to say this is the format that the queries come in. So type, index, and value. And then when type is 0, we need to change all the values in the row. When the type is 1, we change all the values in the column. So let's just kind of take a look at it right now. So we have our initial matrix, again 3 by 3 matrix with everything as 0. And then we have our first query. So if we look at how this works, we have a type of 0, which means we're changing all the values in a row. And then we have an index of 0, so it's this top row here. And then we have a value of 1. So we're going to set all the values in the top row to 1, which is what happens here. So oopsie daisy. So if we then go to the next one, 1, 2, 2. So we want to change all the values in the last column to 2, which is exactly what's happened here. And then this one, row again, so 0, 2, 3. We're going to change all the values in the last row, the bottom row, to 3. Again, exactly what's happened here. And then finally, we have 1, so we're going to be changing all the values in a column. This is the first column, 0, and then we're going to change all the values to 4. Again, exactly what's happened here. So that should be pretty straightforward. But how do we actually solve that? How do we write code to do this? Now, if you're in an interview, the first thing you're probably going to want to point out is the obvious kind of brute force solution, which is to literally just create this matrix. So create this matrix and then go through every query and apply it. And pretty much what they've done here. So this is just for loop, going through every query, keeping track of all the changes, and then at the end, just loop through it and add them all up. That's a perfectly valid solution. It's going to give you the right answer. It's not the most efficient, but in an interview, that's probably the first thing you're going to point out, just so the interviewer knows it. And worst case scenario, if you can't think of any better solution, it's always a good one to go to because it's going to show that you can actually solve the problem, which is the most important thing before you do any sort of optimization. But let's kind of think about how we're going to come up with a better solution, one that's more optimal. So if we look at it here, this is kind of our most important matrix. Like this is where we get the result from. This is where we get 23 from, by adding every single number up here, right? So how can we kind of, right at the end, these numbers are all that matter. So I think something that's useful is let's compare this matrix here, this one after query 1, and then our final matrix. And you'll notice that this value here in this one and this value here and this one aren't actually present in the final matrix. These are actually irrelevant. These don't matter at all, right? So the only value that we care about that's actually significant at all from this one is this 1 here. The other values have been overridden. So you'll notice that these earlier values are often getting overridden, so they're the least kind of important values. Like this query right at the end, nothing's gonna override it. This is the most important query here, because all these 4s are present. We know that our result is going to be at least 4 plus 4 plus 4. It's going to be at least 12, right? Versus these are the least important because they're most likely to get overridden. So originally, when we were talking about kind of going through and kind of creating a matrix and just doing all the queries going from left to right, that's actually not what we want to do. We want to, just from kind of what we've done here, it's clear that the most important ones are happening over here. We want to go the other way. We want to see these numbers first, because these are the ones that are doing the overriding, and then we can kind of fill in any gaps with this. So kind of it's also important to let's compare it again. Let's compare it query 1, right? So this is this query again. So this is done 2. This is added this column of 2s. When we compare it to query 3, this one isn't even present. Again, we've just got data here that isn't even relevant. So that's why we're going to want to start here. So how can we kind of use that technique and use that kind of understanding that these are the most important, and then we kind of work our way down, and we kind of make use of these earlier values and give them a high priority, I guess. So how are we going to do that? The way that we're going to do that is we're going to kind of keep track of which columns and which rows have been filled. So going back to front, we look at which rows and which columns have been filled. So for example, we start at query 3. Let me remove all this stuff. So we start at the end here, and to our result, we're just going to add all of these values because we know they can't be overridden. So we're already at 12. And then once we move, we go here. So we've kept track. Okay, column 0 has been filled. Everything in column 0 has already been filled. So then we go here, and we go, okay, we're filling in this row here, this row 2, and we're adding 3s. So because we already have column 0 as, we already have all the values there. We can't have any more values in it. We don't need to add this. We just need to add 6 to it, right? And then so now we record, okay, row 2 has been filled, okay? Then we go here, okay, we're filling in, so I think it's kind of, might be useful to look at it like this. So this one hasn't been filled, this one has been filled, this one has been filled, this one has yet to be, but is about to, this one has yet, and this one has. So, okay, we don't have any new values in this one, so it doesn't matter, but we do have a new value in this. So we don't care about this. So we're just going to be adding 4 to it, right? And then so now for this one, we already have values in here, we already have values in here, we don't have values in here, we do have values in here, and don't, and don't. So this value is irrelevant, this value is irrelevant, this is the only one that matters. So we're just going to add 1 to it. So that's how we're going to kind of work our way back and just look at kind of just filling in the gaps of rows and columns that have yet to be filled with a value. So I hope that was semi-clear. It's a bit, it's probably going to be clearer when you actually look at the code. So let's jump over to LeetCode and actually write some code. So we're going to be starting to keep track of those rows and values. Let's create a set. So rows equals set and cols equals set. So we have a set of rows and columns, and we're gonna, whenever we fill a row or fill a column, we're gonna update this set with its index. And then let's initialize our result, which is what we're gonna be returning as 0. And then let's go through all the queries from back to front. Now I'm gonna call it type without the e, because otherwise it will cause an issue. So type index val in reversed because we want them back to front. We want them in the reverse order. So if type is equal to 1, which it means that we're going to be filling a column, then we need to check, hey, has this column already been filled? So if index not in cols, so this means that we haven't already filled all this entire column, then we're going to add it so that we don't ever we don't use it again, and then we're going to update the result. So result plus or equals the val times, and I'm going to explain this after I write it, times length, times in brackets n minus length of rows. So this is what we were doing here, right? Where's the one when we're filling columns? Okay, cool. So think about this. Our columns here, our cols set currently has 1 in it because we filled 1 column. So what we're doing is the value multiplied by, this is the amount of cells we're filling. So n, which is, the amount of rows there are and columns there are. So the full width minus how many rows have already been filled, which in this case is 1, which is why we don't fill in this. So that's kind of why we're basically saying this is every single row, and then let's remove any rows that already have a value in it, and then we're multiplying it by the value. And then we're just going to add that to the result. So same logic for type of 0. So if index is not in rows, then let's add it to the rows. And then we're going to increase the result. Result plus equals val times n minus length of cols. Cool. And then let's return the result. So that should be all the code we need. Let's just see if this is actually, if there's any bugs there. Cool, it was accepted. Let's run it. And we passed all the tests. So I hope this video is helpful. If it was, please like and subscribe. Thank you guys so much for watching. Have a good one.